Hello Tachyons, this is Kumar and welcome to the TachyLab. We are doing unit Force and Motion. In this unit, we are going to cover the chapter Movement and Position, and this is lecture number 2. Today we will start with the uniform motion. Now what is uniform motion? If suppose a person or an object covers equal distance in equal time interval. Like here in 1 second the object covered 3 meter. Again in 1 second the object covered 3 meter. In next 1 second again covered 3 meters. So if the object covers equal distance in equal time interval, no matter how small the time intervals are, we say that okay, the object is in uniform motion. And there are several examples to it. For example, a car on a straight highway at constant speed, a clock's minute hand, earth's rotation, all these are examples of uniform motion. But if it does not happen, like same uh, distances are not covered in equal intervals of time or unequal distances are covered, we say it is non-uniform motion. Like here in 1 second, the object covered 2 meter. In next 1 second covered 5 meter. In next 1 second covered 3 meter and so on. So it's changing, it's not same. That means it's non-uniform motion. So in this case, the speed will keep on changing. The speed will be variable. Again, there are several examples to it, and mostly the motion around us, that is non-uniform. So a car stuck in traffic, again the speed is going to vary. We are going to stop, we are going to move faster, again stop or slow down. A swinging pendulum will also slow down gradually. Cycling uphill, the speed will decrease while climbing. A falling object, the speed will increase. Why? Because of the gravity. A train arriving at or leaving a station, so at that point what will happen? Either the train would want to stop, so it will apply brake, or it would want to gain speed, so it will start accelerating. Again, the speed is changing in this case. Measuring the rate of motion. So when we are driving or on a road, we must have seen these signboards, right? There is a limit and we cannot exceed it. Sometimes it's written 65 kilometers per hour or 20 miles per hour and something like that. So these are the limits. What are these? These are telling us that okay, you cannot move faster than this. So measuring the rate of motion, let us understand. Let us say this is home and this is school and this is you, and you have to move from home to school, and let us say you took 10 minutes while your sibling who was slower took 15 minutes. So you were faster and your sibling was slower. How you are able to tell this thing very confidently? Because the distance was same and you both took different time intervals. And if the time was less, then we say that okay, you were faster. That means the speed was more. While if the time was more, we say that okay, the speed is less. That means the person is slower. Now this is an idea, but how do we actually measure it? Let's see that. But before that, if you like my way of teaching and you are able to understand the concepts, do like the video and share it with your friends. For free notes, check the link in the description box, and you can also contact us for one-to-one or small group classes. Let us now understand average speed. So we have seen that okay, distance is there and we are taking less time or more time. So the speed is inversely proportional to it. That means average speed is total distance traveled by total time taken. That how much distance we are able to travel in particular time period tells us about the speed. Distance is measured in meters, time is measured in seconds. So the units are meter per second, centimeter per second, kilometers per hour, etc. Let us do a question now, so you will be able to understand it better. So the object travels 16 meter in 4 seconds. Let us say this is point A, this is point B. So the object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed? So you should know the formula. So V average is total distance traveled. This total word is very important. Total time taken. And what is the total distance? irrespective of the fact that okay, A to B or B to C, in how much time we are taking it, just add it up. So it will be 16 plus 16, so it will be 32 meters. And then what is the total time? Total time is 4 seconds plus 2 seconds, that is 6 seconds. So we will be dividing 32 divided by 6 meter per second. And so it will be 5.33 meter per second here. I hope this numerical is clear. Easy? Let us see now speed with direction. So we have seen distance and displacement, right? The displacement is something that we say that it's a vector quantity. It's a magnitude plus direction. Same way, speed with direction is velocity, which is again a vector quantity. So velocity is nothing but speed of an object but moving in a definite direction. So velocity can be uniform or variable, and we can actually change it by changing the magnitude, by changing the direction, or both of it. And what is the formula? So average speed was total distance by total time. Average velocity is total displacement by total time taken. And what will be the units? It is meter and this is second. So it will be meter per second, centimeter per second, kilometers per hour, or miles per hour. Same as speed. Let us do a question now. Now this question is similar to the previous one, but see how the things will change. So this is, let us say this is point A. So it says an object travels 16 meter west. This is point B. This is 16 meter west in 4 seconds. And then another 16 meters east. So these are another 16 meters east in 2 seconds. Right? And what is the average velocity? So what is the total displacement? So the object started at A and again reached at A. So whenever the initial and the final points are same, the displacement is always 0. So total displacement covered is 0 meters, and now you don't need to add 4 or 2 or do those steps, because the average velocity, which is total displacement by total time taken, it will be 0 meter per second. Why? Because displacement itself is 0. So whenever some question comes and you see that okay, initial and final points are same, the V average or average velocity will always be 0. But if you look at the average speed, it will be same. That will not change. It will be 16 plus 16 is 32. It will be 4 plus 2, 6, and it will give you again 5.33 meter per second. But it's not the same case when they say average velocity. So I hope the difference is clear. Let us now see the difference between both of them. So speed is rate of change of motion. Same way, velocity is also rate of change of motion, but in a particular direction. Speed is a scalar quantity. That means it's only going to talk about the magnitude. While velocity is a vector quantity. That means here there is magnitude plus direction. Speed is always positive. While velocity can be positive, it can be negative, and it can be 0. And finally, formula. Speed is distance by time taken and velocity is displacement by time taken. I hope this contrast is also clear and you were able to understand today's lecture. If you have any doubts or queries, you can put it in the comment box or you can directly contact us via email. Thank you so much and I'll see you in the next lesson.